This conference will now be recorded.
हेलो बच्चों, कैसे हो? बढ़िया. Since this is a small topic, so I'm hopeful of completing this in about 30 minutes. So I thought of I will be recording this rather than having a live session, so that will be equivalently good bit. Righto. So do you people remember that we discussed in the last session about electrode potentials are of two types, oxidation and reduction potential. The oxidation potential is the tendency of the given substance to be, yes, oxidized, to be oxidized. Therefore, the more the oxidation potential, the more is the tendency to be oxidized. Dimensions will be in volts. Reduction potential, it is a tendency of the substance to be reduced, and it will be again given by the volts in units of volt. Any substance can have oxidation as well as reduction potential. OP and RP are equal in magnitude but opposite in sign. We were forced to think that we should make the thing unique. Therefore, the IPEC said that we will be considering standard reduction potential only. That is also called as standard electrode potential. This is always measured at 298 Kelvin and concentration of the ion is 1 molar if gases at 1 bar, right, with respect to standard hydrogen electrode. Now, the standard electrode potential, or conveniently SRP, reduction potential standard, can both be positive as well as negative. Any substance will be having a definite fixed value of the reduction potential. Then we arrange in decreasing order of standard electrode potential. That is known as electrochemical series, electromotive force series, reactivity series. This is a portion of the series. You're not supposed to memorize the data, but at the same time, you are advised to go the location of each element, where it is placed. For example, the oxygen has more reduction potential than bromine. That means oxygen has more tendency to gain electron with respect to bromine, whereas zinc has more tendency to lose electron as compared to the bromine. That's the idea of it. We started with certain application of EMF series also. You were taught the more the reduction potential, the better the oxidizing agent. The lesser the reduction potential, the better the reducing agent. You were said that you should keep in mind chlorine is the best oxidizing agent in the whole periodic table. सबसे ज़्यादा powerful oxidizing agent. Whereas lithium is the best reducing agent. We can arrange the substances on the basis of their increasing or decreasing oxidizing or reducing power. This question is one of the easiest, but most students commit a mistake because they forget what the examiner has asked. One thing you should notice, he has asked increasing order and then the reducing power. Matlab, the most reducing should be on your right hand side. For example, potassium is having minus 2.93. Least reducing, that is silver, should be on your left hand side. So I have experienced, so that is what I am advising you. You should be more careful about increasing or decreasing, reducing or oxidizing. This is the hard term. You are advised that you must make sorry, a list of these elements in your own hand. We do not advocate that you should memorize the data, but we expect that with proper failures learning, you should know what is going to be the order. For example, fluorine, chlorine, bromine, iodine. Iodine is going to be least reducing. Fluorine is going to be most reducing of all the halogens. Metals mein lithium is going to be most active, magnesium lesser, cadmium lesser, and maybe if you're finding here silver, that is going to be even lesser. Gold इससे भी कम होता है. That list has been shared with you. So बच्चों, let's continue whatever we learned in the last class. So this is another application of EMF series, oxidizing and reducing power के अलावा it helps in predicting EMF of the cell. Remember, E cell as used in this relationship has to be always positive. Otherwise, delta G will become positive or reaction nahi hone ka. So it should be always higher minus lower. Ab redox mein, which will be reduced, will be having higher reduction potential. There's no doubt. So you can say cathode minus NO. Because convention पे cathode को हम right hand side पे लिखते थे, तो we can also use the second or third relation. We have already used this, right? Do you remember that zinc cadmium or zinc copper बना लेते हैं? The copper potential is 0.34. This is minus 0.76. So E naught for this cell is E naught for reduced minus E naught for oxidized. This is 0.34 minus of 0.76. This is going to be 1.10 volt. You can cook any cell from here. Yep, any cell from here, right? Whatever you want, you can take it. Or maybe the examiner is going to be asked, बस एक चीज को लॉक कर दो, जिसका रिडक्शन पोटेंशियल ज्यादा है, that will be always reduced. Always reduced. ठीक है? Remember, that has been taught to you already. Always remember, once the equation has been given in the reduction form, right? अगर उसने ऑक्सीडेशन की फॉर्म में दिया है, then you have to first revert the equation. The equation or substance having more Rp will be reduction. The substance having less Rp will be oxidation. The net E naught cell is E naught reduction minus E naught oxidation. And do not change the Rp once you write the oxidation equation. मतलब मैं ये कहना चाह रहा हूं कि बेशक जिंक इज गोइंग टू बी ऑक्सीडाइज्ड, बट यू हैव टू राइट, यू हैव टू टेक its reduction potential only. For example, this is the equation. This is a question. What will be the spontaneous reaction when following half reactions are combined? Always check whether it is reduction potential or not. Only then proceed. This is reduction equations. Now, which is having more reduction potential? This, the MnO4. So this will be reduced. ध्यान से देखो, MnO4 negative, 8 proton, 5 electron gives you Mn plus 2, 4 water. E naught is 1.49 volt. Now बच्चों, what was the meaning of that thing कि आपको चेंज नहीं करना है? The first equation will be oxidized. That is, you have to change, invert the equation. But notice, don't change this, because this was Rp, this was Rp. हमें बेशक कोई चीज ऑक्सीडाइज हो रही है, हमें उसके लिए भी हमेशा ऑक्सीडेशन potential नहीं लेना है, reduction potential has to be taken. Now equate the electron, multiply this by 5, right? Doing so, 5 electron produced, 5 electron consumed, बराबर हो गए. Now मैंने 4 negative, 8 proton, 5 ferrous, reactant को reactant में, product को product में, and 5 ferric will be there. Right? You have to go in this fashion only. There is no other option. No other option. And E naught is going to be E naught reduced, E naught oxidized, sorry, E naught oxidized, that is 1.7 minus 0.77, 0.72 volt. आपने equation भी लिख दी है and आपने वो भी कर दिया. You can check the equation. लेफ्ट और राइट पे सारे के सारा बैलेंस्ड होगा लॉ ऑफ मास सेक्शन के मुकाबले भी और अकॉर्डिंग टू द लॉ ऑफ कंजर्वेशन ऑफ चार्जेस भी. Actually this has thousands of application, not 1 2 5 10. Yes, I really said thousands of application, right? तो चल सकते हैं. Now the next application, it is used to predict storage of electrolyte in different vessel. See बेटे logically सोचो, अगर हम आपको कोई चीज स्टोर करने के लिए बोले, should there be any reaction between the item you have stored and the vessel? For example, आप लोगों को मना किया जाता है, you should not store pickles, jams, jellies in metal vessel. Why? Metal by definition they have tendency to lose electron and pickles must be having acids, तो वहां पे तो रिएक्शन होना जरूरी है. So that is the reason आप देखिए जितने भी pickle, jams, jellies आपने देखे होंगे, never ever stored in the metal vessel. And at the same time we do not advise that you cook your food in that metal where it might react with metal. Of course there are few metals like iron. आयरन के खाना बनाओगे कोई फर्क नहीं पड़ता, बिकॉज बायोलॉजिकली हम जो आयरन एब्जॉर्ब करते हैं दैट इज इन द एलिमेंटल फॉर्म. बट अदरवाइज अगर आप एल्युमिनियम के बर्तन में या कोई और टॉक्सिक मेटल है उसमें अगर आप खाना बनाएंगे तो इट विल बी प्रॉब्लमेटिक. रिएक्शन शुड नॉट हैपन. लेट अस कंसीडर टू केसेस A and B. Here zinc sulfate is stored in copper. Now bete zinc has less SEP, right? याद करने की जरूरत नहीं है, पर of course अगर प्रैक्टिस से हो भी जाए तो बुरा भी कोई नहीं. This has more SEP bete, right? So which is going to be oxidized? Zinc. But here zinc is already present in more oxidized form. वो और इलेक्ट्रॉन लूज नहीं कर सकता है. Copper is sitting in zero. Zero में copper is not going to gain electron. There will not be any reaction, right? And this is going to be considered as a good storage. Whereas if you store copper sulfate in zinc, the zinc will be oxidized, मतलब corrode कर जाएगा. And the copper having more reduction potential will be reduced. आपने स्टोर किया था कॉपर बट यू विल बी गेटिंग कॉपर 0. आपने स्टोर किया था +2. reaction has happened. You will find small amount of zinc sulfate there. The reaction happens. So hence this is the poor storage, right? In general, the vessel where you want to store must have more SEP than the element you are going to store as an electrolyte or as a salt in that. There should be no reaction. And remember, जिसका reduction potential ज़्यादा है उसने reduce ही होना है, and जिसका reduction potential is lesser उसने oxidize ही होना है. The horse will not eat meat. The lion will not eat grass. So this is going to be similar to that. आप अगर सोने और चांदी में खाना बना सकते हो तो हमें कोई प्रॉब्लम नहीं है. If you can afford it, go ahead. There will be no reaction. But equivalently will be the stainless steel जिसमें हम खाना बनाते हैं. आपके कुकर्स, आपके जो बर्तन है, that is made up of very unreactive material. वो react नहीं करता है. So this is going to be homework for you बच्चों. I hope you people understand. At the heart, this series is working. जिसका रिडक्शन पोटेंशियल ज्यादा है उसने हमेशा ऑक्सीडाइज होना है. Displacement reaction. In general, the more negative, that is lesser the SCP of a metal, the more reactive it is. Do you people remember? Metal has to lose electron. Metal has to lose electron. Therefore, what is going to happen? It is going to lose electron. SEP is an indicative of that. And it will displace another metal from its solution. Watch reaction A. ठीक, here zinc lesser, copper more SEP. They will react. Zinc कहेगा भैया मैंने ऑक्सीडाइज होना है और कॉपर कहेगा मैंने रिड्यूस होना है. So zinc has displaced copper. The more reactive zinc has displaced less reactive. Metal की reactivity oxidation. Zinc lesser SEP has displaced copper more SEP. Watch reaction B star. Copper is having more SEP. So how can you imagine this reaction to happen? No, impossible. वही बात होगी ना. The horse will not eat flesh. The other one will not eat grass. Right? So that is going to be happening here. That's the same thing we did. Now this can be extended in this way also. He says arrange the following metals in order which they displace each other. मतलब less SCP, yep, more reactive will displace less reactive. Less reactive मतलब more SCP. तो बच्चों यहाँ पे रिडक्शन पोटेंशियल has been provided. सबसे कम रिडक्शन पोटेंशियल किसका है? Magnesium. Magnesium will be most reactive. It will displace all. अभी लिखता हूँ right hand side पे. Now उससे कम किसका है? The aluminium. Aluminium will displace all on the right hand side. मतलब magnesium will displace aluminium also. Aluminium भी गया. अब किसका नंबर लगा? Zinc का. Zinc will displace all on the right hand side. Zinc भी गया. Iron. Iron will displace whatever will come on the right hand side. And the copper has highest SCP will, yep, displace none. Or you can say it is going to be displaced by all. Do you understand? That is going to be difference. You know, this is very interesting, right? Although in our country, we do not think of applications, we think of rote learning. So that is why people always ask you people to have a knowledge-based type of thing. So अगर हम इलेक्ट्रोकेमिकल सीरीज में से देखें तो देखो कॉपर यहाँ पे पड़ा है. एक मिनट, मैंने गलत बोल दिया, कोई बात नहीं, मुझे आयरन भी उठाना था. और कॉपर यहाँ पे पड़ा है. आयरन +2 का -0., ये कॉपर +2 का 0.34. कॉपर +2, कॉपर 0.34. And iron plus 2, you should write in the reduced form minus 0.4, which is more reactive, more reactive, right? Let us take this plate of iron, आयरन की प्लेट ले लेते हैं और हम इसके ऊपर let us write Shivet. You know, Shiv, right, is a name of the god. Ved is the name of the literature, Shivved. So that is why from where we have borrowed this name, Shivved. So it has all sorts of energy, all types of energy contained in itself. Now, iron plate के ऊपर Shivved लिखना है. We coat wax on iron plate. Do you understand? मैंने इसके ऊपर वैक्स की कोटिंग कर दी. वैक्स मिलता है मार्केट में. आप वैक्स को गर्म करो, पिघल जाएगा ऑयल के जैसे. प्लेट को उसमें डालो, निकाल लो. फिर जब वो जम जाएगा फिर दोबारा डालो, फिर निकालो. ऐसे करके उसके 7-8 बार उसको करो. You will have a thick coating on the iron plate wax. Then carve Shivate on that. Right? Carve. You can take any spatula. Just carve. Right? You can use your name also. This is just an illustration. Now what will happen? The iron will be exposed where you have carved Shivet. You understand? We have carved Shivet here. Now pour copper sulfate aqueous solution and let it stand for about 12 hours, 40 hours. This is experimental. The more you try, the better you will be. Now leave it there. What will happen? The copper sulfate you have added, the iron on the plate, iron is going to be oxidized. It will form ferrous sulfate and copper will be reduced. It will not exactly happen that iron will be going from the plate and copper will be going in its place. So the iron from the plate will start dissolving. And the more the thickness of the wax, you will be getting better result. Then just wash it. Then heat it, heat slightly plate. What will happen? The wax flows out off and you will be left with what? Carving of Shivet. So that is how the metals are etched in this way. It's a simple logical thing. No rocket science. Here too, my wording once again. You can do it whenever you are free in the coming months. It's beta science. And now watch one more thing. This is the H2SO4. Simple displacement. This is zinc metal minus 0.76. Hydrogen standard 0. Reaction will happen. Hydrogen will be oxidized or zinc will be oxidized. Zinc will be oxidized. You will be getting rid of zinc sulfate and hydrogen gas liberated. Now think of another thing. Let us take, you can take HCl also with it or HCl, we don't mind, right? H plus चाहिए and take silver 0.80, हाइड्रोजन के लिए 0. Now क्या सिल्वर ऑक्सीडाइज होगा? क्या हाइड्रोजन लिबरेट होगी? No, not at all. That is, we say those metals like zinc, magnesium, sodium, aluminium will liberate hydrogen from mineral acids within, right? Those metals like this will liberate hydrogen which have negative SCP, that is SCP less than the hydrogen. अरे वही तो बात है डिस्प्लेसमेंट वाला, जिसका रिडक्शन पोटेंशियल कम, more reactive, oxidize, displaced another. Zinc will be displacing hydrogen. पीछे जो कराया था, the zinc will be replacing the copper. The same story. Ditto, same type of thing. So बच्चों, this is the heart of everything you are learning. Really the heart of whatever you are learning. See, this question has been borrowed from your course, but this is +2 का question है. Predict if the reaction between the following is feasible. देखो बेटे, इसका मतलब होगा कि he is asking about that this thing what has been given to you is in the reactant. For example, first को देखो, this is iron +3 plus iodide. इसको reactant रखना है. And now you see उसने आयरन का कपल किसके साथ दिया था, +2. तो इसका मतलब इसको +2 रखेंगे. समझ आ गया ना, क्योंकि दिस वर गिवन रिएक्शन रिएक्टेंट होंगे. एंड आयोडीन किस में जाएगा, I2 में. देखो ना यहाँ पे कपल देखो किस में दिया था. नाउ डू यू अंडरस्टैंड, दिस इज रिड्यूस्ड, दिस इज ऑक्सीडाइज्ड. अगर ये रिएक्शन नहीं होना है तो इनका ई सेल मस्ट बी पॉजिटिव ओनली, अदरवाइज नहीं हो सकता है. चलिए जी, आयरन का पोटेंशियल चेक करिए. ई नॉट आयरन +3 माइनस ई नॉट I2 टू आयोडाइड. आयरन का पोटेंशियल देख के बताओ, 0.77 वोल्ट. माइनस भाई आयोडीन का ऑक्सीडाइज होने का 0.5 वोल्ट प्लस 0.32 वोल्ट. दिस रिएक्शन is visible, spontaneous होगा. Check once again. I will not do all. You will do the other one. Let us check fifth. 5 में से 2 या 3 मैं कर देता हूँ, बाकी आप करेंगे. ब्रोमीन एंड अब की बार बैलेंस. ये किस में जाएगा, ब्रोमाइड है. You can balance, you might not balance. Entirely your choice. We have no objection. And this goes to iron +3. ठीक. Br2 reduced. E नॉट देखो भी कहां पे लिखा है, 1.09. Iron is oxidized. Iron minus 0.77, 0.32 volt. This is also going to be visible. समझे? एक और करते हैं बस. ठीक, लेट इट बी सेकंड कर लेते हैं. बाकी आपका होमवर्क रहेगा बेटे, आपके लिए दिया गया है. सेकंड कर लेते हैं. I'm doing it random. सिल्वर का कपल Ag प्लस के साथ, कॉपर का +2 के साथ. आई होप मैं कहां से कपल ढूंढता हूं. This is being reduced. Silver is being reduced. 0.80. Copper 0.34. This is plus 0.46. होगा, right? Certainly होगा. बस आपको ये माइनस चेक करना है एंड बी फर्म फुटेड. जब माइनस आ गया तो उसका मतलब वो नहीं होने वाला है. ऐसे ही आई एम डूइंग द थर्ड वाला. ferric, bromide, ferrous, and bromine. Ferric is being reduced. उसका potential क्या है? 0.77. Bromide is being oxidized. Volt. Check करो. Minus 0.32 volt. Not possible. Not possible. Please check all of these once again. I'm telling you the way of thinking. I'm not telling you everything. You must do other things also. Potential has to be positive. जहां मर्जी जाओ. अब एक और चीज देखो. Electrolysis is reverse of energy producer. It takes energy. यहाँ पे एनोड पे एनायन जाते हैं because anode is positive. The cathode पे cation जाते हैं because cathode is negative. Never ever forget that at anode happens oxidation. At cathode always happen reduction. This is good. This is fundamental. But if there is a clash, competition, what we say, there is only one species की seat है reduce या oxidize होने की, and there happens to be more than one cation or anion. For example, let it be वहां पे सिल्वर और मैग्नीशियम दोनों पहुंच गए 0.80, याद मत करना 36 वोल्ट. ठीक. Now this will be reduced first. क्यों भाई? More SCP, more ease of reduction beta. Understand? Now anode पे the chloride and OH negative पहुंच गए. That will be oxidized, which has lesser SCP. This has the more tendency to be oxidized. So this will be oxidized first. Do you understand? Cathode पे more SCP reduced first. Anode पे lesser SCP will be oxidized first. If you want, and I'm telling you, this can be a lottery, है ना? Lottery. That anode पे you understand गुरु मंत्र. एक word ही रखना, bonds, right? Chloride, OH negative, nitrate, sulfate. Chloride, OH negative, nitrate, and sulfate. This will be oxidized first, and this will be oxidized last. First oxidized. Never ever this will give you pushback. नहीं देगा. Remember that. So never ever forget you. Cons and node पे order. ध्यान देना. Chloride, OH negative, nitrate, sulfate. Chloride will be oxidized first. अब एक और चीज देखो बेटे. वाटर की इलेक्ट्रोलिसिस 4H plus 4OH negative. I know थोड़ा सा आपसे ज्यादा तो मैंने बैलेंसिंग कर रखी है. This goes to ideally cathode, reduced, anode, oxidized. This eats up 4 electrons to produce 4 hydrogen atoms to 2 water. This loses 4 electrons to form, ये intermediate है, 2 water plus O2 will be formed. So if I write बच्चों the net reaction 4 water 2 this, 2 this, 1 this, 2 water, right? 2 H2 and O2 नहीं रहेगा. Bring it here. This will be the net reaction. Why I'm doing it? You will be doing this thing in your class 12th, but due to the application of EMF series, your examiner has put this question here. Predict, this is an NCERT problem, of electrolysis in each of the following. An aqueous solution of silver nitrate, एक एक करके करते हैं, मैंने अपनी तरफ से डिवाइड किया हुआ बेटा इसको, ठीक है जी. तो एक एक करके इनको करते हैं. ऑल आर टिपिकल केसेस बेटा. हम +2 में जाके आपको और ज्यादा करवाएंगे बिकॉज इलेक्ट्रोलिसिस वहीं पे ही आएगा. Predict the product of electrolysis in each of the following. An aqueous solution of silver nitrate in silver electrode. This method is used for refining of impure metal. Is refined. What we take is, we take pure metal, इसको silver, कैथोड बना देते हैं. Impure metal, of course silver उसने बताया है, इसकी एनोड बना देते हैं. Now what happens? This is the diagram, right? Although आपको इसकी जरूरत नहीं है, but still अगर जितना ज्यादा करें तो समझ ज्यादा अच्छा आता है. We are putting silver nitrate here. This is silver and this is silver. ये क्या है? कैथोड और ये क्या है? एनोड. And we are putting the battery to this, और energy इसको हम दे रहे हैं. This is the rough sketch. Do you understand? Here anode पे silver will be oxidized. ऐसा ही होता है, right? Anode पे silver is oxidized. Cathode पे the silver is reduced. So what will happen? The impurity will fall here in the form of anode mud. ध्यान से देखो, actually what is happening? Silver is being oxidized, silver is being reduced. इसकी थिकनेस धीरे धीरे करके कम होती चली जाएगी और इसकी थिकनेस बढ़ती चली जाएगी. We will get almost 99 point pentanine heptanine silver is going to be produced. So aqueous solution of silver nitrate with silver electrode, silver is oxidized, silver is reduced. It is used for the purification of metal. ऐसा ही कॉपर के लिए भी किया जाता है. यहाँ पे कॉपर सल्फेट ले लेते हैं, कॉपर इलेक्ट्रोड, copper get oxidized, copper get reduced, and this is the anode mud. And copper की electrolysis में, for your general knowledge, we get lots of costly metals like gold, silver, platinum जैसे मेटल मिलते हैं, और वो इतने महंगे होते हैं कि वो इलेक्ट्रोलिसिस की कॉस्ट को पूरा कर देते हैं. Now this is with the platinum electrode. The platinum electrode बेटा, देखते हैं वैसा ही डायग्राम है बच्चों. यहाँ पे अब हमने प्लैटिनम इनर्ट एनोड ले ली और यहाँ पे हमने प्लैटिनम की कैथोड ले ली. Here we have no restriction, left पे कैथोड रखना है या राइट पे कैथोड रखना है, ऐसी कोई restriction नहीं. We are into the second part. Now the cathode and anode. एनोड पे पॉजिटिव, कैथोड पे नेगेटिव। एनोड पे केटायन जाएगा, कैथोड पे केटायन जाएगा। Silver will go, and please don't forget it is aqueous. Water will also produce HN. Got it? Anode पे the nitrate will go and the OH negative will go. Just for the sake of simplicity मैंने पूरी इक्वेशन को 2 से मल्टीप्लाई कर दिया, ना भी करते कोई फर्क नहीं पड़ता। अब एनोड पे कौन समझ आया? अगर नाइट्रेट भी है और OH नेगेटिव भी है, so this will be oxidized first. That will produce water, right? And oxygen -2 electron. Silver 0.80, hydrogen 0. So which will gain electrons? Silver. 2 silver. And you will get a bonus of nitric acid. Do you understand what I'm saying here? What I'm saying is you will be getting a mixture. Silver will be produced, cathode पे एनोड पे ऑक्सीजन आएगी। पिछले वाले केस में एनोड पे सिल्वर was being oxidized, यहाँ पे OH negative is being oxidized, and see nitric acid remains as such. वही मैंने उसको डिवाइड कर दिया बेटे, तो I'm into third part. The third, predict the product of dilute H2SO4. Dilute H2SO4 is nothing, electrolysis of water, right? This is going to give you, दो ना भी लगाता तो वही तो जो आपको अभी करवाया था यहाँ पे, एक सेकेंड बेटे, ये राइट, इसको यहाँ से उठा के ये देखिए ये इसके साथ है। There's the same thing. H2SO4 is added to increase ionization of water. Water is a weak electrolyte, it does not dissociate, तो water की electrolysis as such होती नहीं है, so it is done with the help of the little bit of acid or base is added. यही चीज जो आपको दिखाई गई थी। Last, an aqueous solution of CuCl2 with platinum electrode. अरे डायग्राम भी बनाने की जरूरत नहीं है, एनोड पे कैथोड पे there is no restriction left or right, कहीं पे भी लिख दो, एनोड पॉजिटिव कैथोड नेगेटिव। अब देखो जो कैथोड पे केटायन जाएगा, कॉपर will go from cuprous, proton will go from water, the chloride will go from Cl2 and H plus will go, anode पे OH negative will go from water. Which will be reduced? Copper. Reduction potential ज़्यादा. Which will be oxidized? ये किसी को दिखाना मत, आपका है, chloride है. You will be getting this, and what will be there? Water बेचारा as such by the, मतलब basically you will be producing copper and the chlorine, right? Understood? So my dear friends, these are just few applications of electrochemical series, and we have come out of a beautiful chapter known as the redox reaction. So it is a different type of chapter. You will not see balancing in class 12th. Rest everything you will see in class 12th under the name of electrochemistry. I wish you should draw this list with your own hand. Right, Bachcho? So till then, good luck and see you again with the next chapter very soon. Bye, Bachcho. Good luck and see you again with it.